So let's talk about these 4 principles that can make architecture successful in an agile reality. The principles are, first of all, about decision making, about looking at architecture as a function that actually makes decisions. The second is about how to prioritize those decisions. And of course, business impact is key there. The third is about how much into the future you have to look, how much anticipation you should use in your architectural design. And then the fourth principle is about the changing role of the architect and doing architecture as teamwork. And we'll zoom in to each of those in the following minutes. And the first one we want to look at is the architecture as a stream of decisions. Traditionally, architecture is looked at as something that is mostly done upfront. Before you start building a solution, you design the architecture of that solution. And organizations would normally have an architecture department that would be in charge of that, or at least have a very important role in that design. And they would start off with giving an architecture guidance document, sometimes called the project start architecture or a software architecture description document. And then later on, they would sometimes also check on the team and see if they were still compliant with the architecture as originally designed, and if they had any deviations that needed to be taken care of. Well, this way of working does not fit well in the agile reality. The upfront design document is called big upfront design, right? And that's a bit of a swear word in the agile world. And the checkpoints later on, these are referred to as mind your own business. We are a self-organizing team. What are you doing messing around in our affairs, basically? So this model of architecture does no longer work in agile reality. And especially this big upfront document that contains, the essence of the architecture, that no longer really exists in agile reality. It is more something that is sort of evolved over time. So it becomes less important, basically, than the role it used to have in traditional architecture. So traditionally, the main deliverable of an architect would consider to be the architecture document, right? That was their reason for being on this earth. You created architecture documents. And this caused a number of issues, one of them being that they were sort of detached from what was going on in the world after they had finished the design. And the way to solve this basically is to actually start looking at the architectural decisions, the individual architectural decisions, as the primary deliverable of the architecture function. And because it's smaller, basically, right? It's or to say it in another way, it's a finer granularity artifact. And that enables you to actually, for example, have a quicker feedback loop with your stakeholders about an individual decision. It's much easier to have a quick back and forth with your business stakeholders, with the technical people, with the security people, with the team that has to operate the solution, etc. That's much easier to do for a single decision than it is to basically get feedback on a whole architecture document. That's not to say that in the agile world, you no longer produce big architecture documents, but I would say that it has changed in the sense that they are sort of almost a byproduct of your communication needs with your stakeholders. The essential thing that you produce as an architect is the architectural decisions. And from time to time, you have to sort of gather up a bunch of decisions that you have made over a certain period of time. For whatever reason, you need to show the resulting models and the resulting architecture to stakeholders, maybe for getting a budget approval or for doing some planning or something like that. So that is the main reason why in an agile context you want these decisions to be considered the primary deliverable of the architecture function. That also gives us something else, which is timing. You may have heard that in an agile world, people advocate delaying decisions, making decisions at the last responsible moment. So, you know, what is that last responsible moment? Well, that depends, of course. For every decision, there's probably a different last responsible moment. And that's what this slide is about. And, you know, if you create this big architecture document where you sort of have gathered all of the decisions and you have them all approved at the same time because they're part of the document that is being approved, you're sort of forcing all of the decisions to be synchronized at one point in time. And as an architect, you probably would have rather liked to delay some of these decisions a little bit because, you know, if we wait a month, we have more knowledge and we make a better decision. But, you know, we have to make it now because otherwise the document is not finished and we cannot get approval for the budget, etc., etc. So those are the reasons. That's another reason to look at these architectural decisions as the primary deliverable, because it allows you to be more flexible in when you make which decision. As you can see on this graph here, that timing is basically a trade-off between the risk of making the wrong decision and the cost of delaying the decision. And the risk of the wrong decision tends to become lower over time because you get more knowledge. You know, either by actively researching a topic or by starting to build stuff and finding stuff out. And the cost of delaying a decision usually tends to rise, and sometimes rises quite sharply. For example, if you are getting close to a deadline, or you need to order hardware, otherwise, you know, the stuff won't be in time for making the deadline. So that's basically the trade-off you have to make. And if you are able to do that on an individual decision level, you are more flexible, you are more agile than if you make them all part of a big architecture document. So if you say that you know, the architectural decision is the primary output from the architecture process, then you basically saying that architecture is a decision-making discipline, and that means that you have you can basically reduce it to quite a simple workflow where you start with identifying and prioritizing the architectural concerns, which are basically the topics that you need to decide about. This will be in a backlog, and then you prioritize that backlog, and then you research the possible, you know, ways to addressing these concerns, and then you make your decisions. And that will, of course, lead to your primary deliverable. And now the question, of course, becomes, okay, how do we prioritize that backlog? How do we determine what is our next piece of work? What is our next piece of research that we have to do? And the answer to that question, of course, is usually in an agile world, business value, right? So we need to address those concerns that have the highest business value associated with them first. And here is a little possible trap that you can walk into, because the business value of architectural concerns is usually something different from the business value of the user stories that they are related to. You can have a very valuable user story that has very little risk associated with it, and it doesn't really require that much attention from the architect. And the reason for that is that the business value of the architecture function is in risk and cost control. So rather than first dealing with the concerns that are associated with high value user stories, we actually need to first focus on those that have high risk associated with them. Because even very, you know, trivial user stories can require something from the solution, some architectural complexity or something like that, that entails a high risk. And that is why we can get to the next principle, which is, let business impact determine your focus, but the business impact in architecture is about risk and cost. There's a very nice article already 20 years old from Martin Fowler, Who Needs an Architect, where he sort of goes into this. He says architecture is about the important stuff, whatever that is. Well, we say what is important can be measured by the risk and cost impact that the concern has. And that also means that the primary business goal of architecture basically is to get risk and cost under control. This has been extensively researched, by the way, in some work, for example, by Raymond Slot, his PhD thesis. And it's quite clear that those projects that apply architecture practices have a much better risk and cost control. They have reduced uncertainty in the feasibility of the solution. They have a reduced risk of delivery troubles. The solution cost, the cost estimation of the solution is much more predictable if it's based on an architecture. And those projects that apply architecture practices have a considerably lower average budget overrun. So those are all risk and cost related aspects that are helped by applying architecture practices. And this brings us to the name of the approach that we have developed based on all of our experiences. It's called risk and cost driven architecture. And it's basically a set of these 4 principles that you just saw and 13 practices that are based on that view of architecture as a risk and cost management discipline. Because they are practices, they're not complete process descriptions, but they are basically proven ways of achieving a single measurable thing, like making one architectural decision or doing one stakeholder workshop, things like that. And that's what basically helps us, fulfill our architecture responsibilities. If you look at architecture as risk and cost management discipline, then it might be helpful to look at this visualization of risk and cost over time. This is actually quite an old visualization. It's called the cone of uncertainty. It was developed by Steve McConnell and Barry Beam back in the 80s, and part of project management lore, basically. And what this diagram shows is that at the beginning of a project, there's a lot of uncertainty, right? The costs can be much higher or much lower than you have anticipated, right? And that uncertainty sort of reduces over time. In the beginning, it's reduced much quicker than later on. But as you are building the stuff, then you learn more stuff. And basically, this is what architecture does. Architecture narrows the cone of uncertainty by researching solutions and by making decisions. Every decision you make sort of reduces the uncertainty of the people or for the people and the teams that have to implement that solution. So that's very useful visualization. The next question that you can ask, of course, is, okay, how does that work? Because you talked about projects, right? The cone of uncertainty being from project management lore, but we don't do projects anymore. We now work agile, and we don't build one thing and then it's finished, the project's over. No, we have products that we maintain in an agile manner, using user stories, using epics, using features that go into a backlog. And the architecture work is actually not concentrated in the beginning of a project, but it's actually more evolutionary and it goes on over time. Well, you can you still do the architecture work, but it's of course it's applied to a single feature or a single epic that is in your backlog. So the cone of uncertainty, basically in an agile context, is something that happens for each individual epic and each individual feature. So each epic starts with a lot of uncertainty, and then once it goes through its Kanban lanes, it will be analyzed, it will be refined, and that's when the cone of uncertainty is narrowed, and that's when the architecture work is done. for each epic and feature. So the next principle is about anticipation. How far ahead in time should we look in our architecture? And there has also been some work done by the same Barry Beam, the inventor of the cone of uncertainty, on how much upfront design, for example, you should be doing when in any project. And his analysis points to three main factors that will help you determine how much upfront design you should do. And those three main factors are business criticality, size, and volatility. Business criticality, because if something is very business critical, you'd better do some more thinking ahead, some more upfront thinking, because making mistakes and trusting the fail early and fail often slogan is quite expensive if you have a very business critical solution. Actually, that's almost the definition of business criticality. It's that if something goes wrong, it's very expensive. And the second factor, size, which also includes complexity, is also very understandable. If you have a very large solution that you have to build, or a very large epic that you have to refine, then you'd better do some more upfront thinking, because large systems and large solutions are harder to change later on than small stories. It's like, you can compare it to a big tanker, a big ship, which takes over half an hour to make a 90-degree turn, where if you're in your little sailboat, you can do that same turn in a matter of seconds. The third factor, volatility, is about the amount of change in the context of the solution. And that works the other way. If there's a lot of volatility, then it doesn't make sense to do too much upfront design. Because if you spend 2 months doing a design in a world where that changes every month, then you can throw away your design right away, because the world has already changed. So those three factors will help you decide where you want to be in terms of how much design you need to do before you actually commit to that architecture. Another way to look at anticipation is with a metaphor from the scaled agile framework. And the metaphor is the metaphor of the architecture runway. So in that metaphor, the architecture of a solution is a runway, and the business features that have to land on that architecture, they are like airplanes that have to land on that runway. And if your business features are all very simple, that can be compared to small one propeller planes like little Cessnas, it's probably good enough to have a 300-yard grass runway. But if then somebody calls you up and tells you, we have this business jet that has to land here in 6 months' time, you'd better start looking at your runway and maybe start pouring concrete. Because if you then wait until the business jet is making circles over your head, you're going to get a plane crash, right? It's too late to start with pouring the concrete then. And that's what you might get by following agile dogmas like YAGNI. YAGNI means you ain't gonna need it, right? So if the architect comes to the Scrum Master and says, we have to start pouring concrete now, and the Scrum Master says, oh, I don't see that business plane, so let's and there's a lot of other functionality that has to be built, so let's work on that first. That is YAGNI, and if you apply that like a dogma, then you run a lot of risk. And of course, what this means is that you need to understand the dependencies between the business features that are anticipated and the architecture changes that you have to make. So doing just enough anticipation depends on dependency analysis, on technical debt control. Technical debt is like your runway sort of deteriorating over time. It needs to be maintained. Or maybe you have a temporary extension of the runway that you then need to refactor. That's technical debt control. And it all comes down basically to an economic trade-off. You need to understand the economic reality. How likely is it that the business jet is going to be here in 6 months' time. And how much value is it actually going to bring? Is it actually worth pouring all that concrete? All of that goes into what we call architecture road mapping. What we use to reason about that value, to do that economic reasoning, is a model by Philippe. And that is a coloring model of the things that are in your backlog. By the way, we're talking here about the solution backlog and not about the architecture concern backlog. This is work for the agile teams to do. And this work can be divided into basically stuff that is visible to end users and stuff that is not visible to end users. You can say it's under the hood. That's on the right-hand side in this model. And both of these have positive and negative variants. So the positive form of the visible user stories, those are the regular user stories. They produce direct business value. This is about added functionality and stuff like that. And the negative version of that is getting rid of defects. And then on the invisible side, by the way, these stories are called enablers in SAFe, which is a logical name because they enable the visible stuff to be made later on. There also we have positive and negative value. So the positive value is colored yellow. And here we're talking about pieces of architecture runway, like, I don't know, an API gateway, maybe. An API gateway is invisible to end users, but it enables people to build, for example, mobile apps that can communicate with the systems behind the API gateway. So it is a typical enabler. It's a yellow backlog item. And then there's the black, which is the technical debt. The backlog item, of course, is the removal of the technical debt that's there. And that is negative because you pay interest on technical debt. So if you want to know whether a user story, an enabler, is yellow or black, the only question you need to ask is, are we paying interest? As long as this is not fixed, are we suffering? And the suffering can be in the form of a team being less productive, or it can be in the form of risks that you run. And this is a very helpful visualization because it helps us to visualize the indirect business value of enablers, which of course are very important to architecture. This is where the architecture runway is built, right? And being able to reason about that value is very important, because if you're not able to reason about it, then people are going to ignore it. And this is what sometimes happens in agile organizations, is that only the green stuff is being realized because people are not able to sort of calculate the indirect business value of the yellow and the black stuff, and that leads to big trouble. So how does our architecture process fit into all this? Well, you can visualize it like this. You see on the bottom here, you see the normal sort of Scrum picture where you have a solution or product backlog, which feeds into a sprint backlog, and every sprint you produce a solution increment and you realize the stories in the sprint backlog. And then you have this daily stand-up meeting with little curl on top of that. What we have done is, on top of that, we have actually drawn the curl of the architecture microcycle, which, if you remember, is about addressing architectural concerns by making architectural decisions. And these decisions, of course, lead to the yellow and the black backlog items, where the green and the red backlog items usually come from the other stakeholders, like the business stakeholders. Yeah, so now, once you have this picture, you can start imagining, well, what would happen if we prioritize all of this in a certain way? For example, some product owners learn that they always have to prioritize by direct business value, which means that they always prioritize the green stuff over the yellow and the black stuff. Well, if you do that too naively, what will happen, of course, is that the black stuff will accumulate in the product backlog. And the more black stuff you have there, the more interest you pay. And that is, of course, a big risk. And sort of visualizing the backlog this way will help you or help architects to communicate about the business value of the architecture stories to the business stakeholders and help them make the right decisions about in which order to implement these stories. And this is an example of how you could do that using dependency analysis. And this is what our practice that we call architecture road mapping, where you start by talking to stakeholders and identifying the events. These are the little gray boxes with arrows underneath them at the top here of this diagram. Those are events that have a lot of impact on the cost or the risk or the value of the solution. Like we have new reporting regulations. Well, you know, we have, if we don't have our that functionality ready before these new rules come into play, then actually our solution will lose all of its value. So that's a very important dependency. But it can also be, like the picture shows here, that a competitor has announced that it will release a shiny new version of their product with a great feature that we actually need to be in place in our own solution as well, or maybe even something better, before they release their next release, because otherwise we will lose market share. And here you see a visualization where, you know, the arrow of the green F functionality that we want before the competitor releases it actually depends on a piece of architecture runway that we actually need to have in place before we can start building that functionality. So this visualization will help you sort of visualize the order, the dependencies in which you realize your story, and then it will help you reason about the business value. This is an example of that reasoning. Here you see a strategy for road mapping, which we call value first road mapping. And in that strategy, you start with all the green stories, right? And they produce a lot of business value very quickly. But of course, after a while, you cannot avoid also having to build some architecture and getting rid of some technical debt. So the yellow and the black will eventually have to be done. And once that happens, of course, it will take away some of the capacity that you had previously spent on the green stories. And that will mean that the steepness of the green value line will decrease, right? The value will increase less rapidly. And that might be a problem because if we didn't manage the expectations of our stakeholders and tell them that this was going to happen, then they will be very disappointed. They will think that the green value line will remain as steep as it was in the beginning. And then if you tell them, yeah, but now we have to do some technical stuff, some under the hood modifications, they might even ask you, oh, that's fine, I'm a bit disappointed for the delay, but I'm sure you are going to pay for your technical stuff yourself, right? Not realizing that actually that is part of their own solution and it's needed for their own functionality. So that is a very difficult conversation that sometimes architects have with stakeholders. There is the opposite of value-based road mapping. It's architecture first road mapping, in which you start with a big yellow blob. This is the architecture framework. And in the beginning, you build hardly any green stuff, any functionality. But slowly, as the architecture becomes more and more perfect, you start adding the functionality. And of course, after a while, the architecture is so perfect that you can build the green user stories on top of that. Just like that, right? It's not even programming anymore. It's more like configuration, and new functionality will come to light. And the value will increase in the end very rapidly. That's the theory. Of course, there's two big risks here. One is that the context changes, and actually the architecture that you have built turns out not to be the right one for the changing context, or you have misunderstood that. That's one risk. And the other risk is that the green value line here remains below the red cost line for a long time. And that means that if you're not very careful, by the time of release 0.2, some stakeholder might say, well, you know, I don't believe in this solution anymore. It's only costing us money, right? It's never delivering more than it costs us. And there, once again, stakeholder expectation management is very important. There is a third way of doing architecture road mapping, which is much simpler. It's called capacity allocation, where you decide or you agree with the team and with the stakeholders that a certain percentage of the capacity of the teams is dedicated to the user stories, the green stuff, and a certain capacity is always dedicated to the enablers, to the yellow and the black stuff. And that, of course, will cause your value and your cost curve to rise in a more regular way. However, it does make it harder to deal with dependencies. And sometimes you are forced to sort of spend more than your 25% on a particular piece of technical debt or architecture runway. All right. So that brings us to the last principle, which is architecture is teamwork. So, as I said before, you know, in traditional settings, architecture was something that was done mostly by architects. But what we see more and more is that actually architecture is being done by teams. And this has to do with the change from upfront to evolutionary architecture. So on the left-hand side of this slide, you see a screenshot from the Agile Manifesto with the infamous sentence that the best architecture's requirements and designs emerge from self-organizing teams. And you know, the big misunderstanding here being that emerge means that it will happen automatically. That's not what this sentence is about. This sentence is actually about responsibility, about the organization of the teams. Who owns these architectural decisions? That is what this sentence tries to convey. You see on the right-hand side here on the top, you see the classic way of doing architecture, where the architects would draw up some hard rules, put those in an architecture description document, and then leave the rest open to the developers. And that was upfront design. But in evolutionary architecture, you start up with a few hard rules because, you know, some things never change. But there's this big gray area of sort of suggestions where you have an intention maybe to do something in a certain way, or you present a number of possible solutions, and you present the trade-off criteria between those solutions. And there is a shared responsibility between the architecture department or the architects and the developers, the team that is delivering the solution. And basically, successful architecture here is always about the interaction between architecture and development. Architecture becomes much more a vertical function that connects levels of abstraction. If you're interested in that, think about the architect elevator metaphor, right, by Gregor Hopi. Look at that website, architectelevator.com, org, I don't know. So basically what it means is that the architects, if you still have them, have to work together with the teams to evolve a successful architecture. How would you do that? Well, there's several practices for that as well. This is a very nice visualization from Stefan Todt. Stefan basically says that there's this whole spectrum of fully crowdsourced architecture on the left-hand side and fully centralized architecture on the right-hand side. Where on the left hand you have no named architect, and on the right hand you have the classic architect that basically decides, you know, the boundaries in which you can work. And there are several models in between here: architecture marshals, architecture owner. I won't go into the details of those. But there are basically ways of distributing architectural ownership more or less centrally. And where you want to be on this spectrum, of course, depends on, not on dogma, but on your business context. If you have small projects, it's a small team that's working all in the same location, And maybe you don't need that named architect. And then maybe, you know, if it becomes more complex and people are divided over more locations, and there are some components in your architecture that really require a lot of knowledge to treat, you know, correctly, then maybe you want to assign architecture owners or architecture marshals for those components. And then, you know, when it really gets safety critical, for example, then maybe you want to go more into the direction of the classic architect. So that's basically it. That is all we have time for now. And that concludes the principle of architecture as teamwork. So we have now discussed all 4 principles, and we have discussed the 5 responsibilities of architecture that help us in CGI, but also in our client base to do architecture successfully in an agile context. The last slide here contains a list of references that are all sources of the material that I've presented. And I also wanted to point out to you once more the 3 columns in IEEE software that you might want to also read, because they contain some more background information and some more details about all of this. Okay, that's it for now. Thank you very much.